Hey everybody, so we're starting a new chapter today on forces, which is chapter 2, and we're also going to be going into Newton's laws of motion, first, second, and third law, just the very basics. We're not going to be going into so much detail, but just so you have a basic understanding of the laws involved. So when we talk about a force is considered either a push or a pull. And a force has, just like motion, just like speed or velocity, it has a strength and a direction. And the unit for force is the Newton, or just represented by the capital letter N. Now, when we talk about net force, and we're just going to be going over some words or some vocabulary that you're going to be responsible for, that we're going to be using often, and you need to understand what they mean. So when we talk about a net force is basically the combination or adding up all the forces that are acting on a particular object. So remember I said a force is a push or a pull. So you pushing on a desk is considered a push. That's you're exerting some sort of force on that desk. Now, there are two types of net forces. One is an unbalanced force, and the other is a balanced force. Now, an unbalanced force basically results in causing the object to move. So if I'm pushing on a desk with a certain amount of force, and Eugenia is pushing against the desk in the opposite direction, but she's pushing harder. So that is an example of an unbalanced force, and I'm going to show you what I mean by that. And that's going to cause the object to move. If, for example, two people are pushing on something in opposite directions, and they're pushing on something with an equal amount of force, that does not cause the object's motion to change. So that we call that balanced forces. Examples of balanced forces that you may not think about that are that we come across every day is forces that involve gravity as well. And we're going to talk about gravity in a little bit. But for example, a book is sitting on a desk right here. Okay. Now, you don't realize this, but gravity is pulling the book downwards. It's pulling the book towards the earth. Okay. Now, at the same time, the table that the book is sitting on is actually exerting an opposite force. Okay. Equal and opposite force, which is why the book is not moving. So if the book is just sitting there, it's not moving. It's because gravity is pulling downwards on it, but at the same time, the table that it's sitting on is pushing upwards. And we call that a balanced force, which is the reason why things don't move when they're placed on a table or a chair or whatnot, and they're not moving. Same thing with you. You standing on the ground, gravity is pulling you downwards, but the floor is pushing you upwards. Obviously, you don't realize that push. It's so minimal. You don't understand it because the earth is so big. And again, we're going to talk about gravity a little bit more. But you're not moving just because the forces are equal and opposite. So these are examples of balanced forces. So these are just little diagrams showing you unbalanced forces. So if you have this object here, whatever this is, and the force of gravity is pulling it downwards at 800 newtons, so this is the value and the unit that we talked about, and something is pulling it upwards at 1,200 newtons, well then the net force, and let me change colors here, the net force is 400 upwards. So 400 newtons, and in which direction? Upwards. And you could see the difference. And this is like basic, like adding integers. Same thing here. If the force of gravity is pulling 800 downwards, and this is pulling 600 upwards, well then the net force is 200 downwards. Okay, same thing here. Here the forces up and down are balanced, but there's a force acting on it to the left. So the net force is 20 newtons to the left. Some more examples of forces. Sometimes they're represented by an arrow. And this is really simple. So 5 newtons acting to the right and 5 newtons acting to the right, net force is 10. Okay, if these are equal and opposite for this number here, equal forces but in opposite direction, well, the net force is 0, so it's balanced. Okay, whereas this is unbalanced. And this is balanced. Let me write it down here. And this would be unbalanced. And the rest of them are unbalanced as well. Okay, so these are just examples of how we would calculate net force and whether they're balanced or unbalanced. Now, friction, I'm just going to mention very briefly right now because we're actually going to do a lab this week on friction. And friction is basically the force that surfaces exert on each other when they rub against each other. Okay, and the strength of this friction, so how strong the friction is, depends on 2 things. It depends on the type of surface that you have. So obviously it's harder to slide something across a bumpy surface than it is to slide something across a smooth surface. And think about floors too. Like if you notice the floor in our room, in the science room, is kind of bumpy. It has like these little tiles, whereas in the hallway it's totally smooth. So if you're trying to pull something across the floor, it's harder to, you need more force to do it when the surface is bumpy. Also, you have to think about how hard the surfaces, or how hard the surfaces push against each other. Okay, so the heavier something is, if it's pushing harder against the surface, the harder it'll be to slide it across. So again, friction is how it's the force that's exerted when 2 surfaces are rubbing against each other, and 2 things that depend on that. One is how hard they push on each other, and the other is the type of surface. And we're actually going to do a lab where we're going to test different types of surfaces and see how much force is needed to pull a sneaker across different types of surfaces. We'll do that next class. And we'll also talk about the different types of friction. I'm going to stop it here, and we'll talk more about it in class this week.